This is 6.3, the numerical model in biomechanics. This is by Jarvis Chater. So what is the numerical model? The numerical model is related to biomechanics and is the actual physics related to sports. There are different parts of the numerical model that can be broken down, and one of them is kinematics, which is the actual motion of objects, and this encompasses linear motion, which is motion in a straight line, curvilinear motion, which is a curved motion, angular motion, which is motion around an axis, general motion, which is linear and angular motion together. Kinetics is slightly different and is based off the forces involved in the movement of that force or body. There are two types of kinetics. There's linear kinetics, which can be things like force, gravity, mass, and weight. Angular kinetics, which is about moments, levers, torques, and couples. All of this can be used to put together a numerical model that can be used to, these different factors can be broken down and analyze a certain athlete or a certain performer, and so they can be broken down, each one into much more detail, and the athlete can have an analysis based on different parts of this type of motion. So for example, a gymnast might perform angular motion on a bar, a movement around the axis, and you can calculate the angular momentum, the height, the gravitation, their weight, and how they move around that axis at speed, and the angle that they do it at. And this can be helpful to analyze different movements and show different ways that athletes do perform different actions in their sports. In the numerical model, there is quantitative data analysis. Now, a quantitative data analysis of the numerical model can be assessed through values analyzed from specific testing done to analyze the players. For example, when testing the speed of a sprinter in a race, the distance can be taken, and their time is recorded into how long they complete the race. So, for example, a 100-meter sprint done in 14 seconds using the equation speed is equal to distance over time. Therefore, 100 meters over 14 seconds is around 7 meters per second. This data can be analyzed by comparing with other competitors and elite athletes. This can be used to show how they need to improve and how good they are currently. In sports, they accompany many areas of fitness. For example, basketball, American football, rugby. These sports use many different areas of fitness. Therefore, these tests can be put together and done on various fitness aspects, such as strength, power, speed, agility, and can be used to put towards training plans together and help them improve to get towards the goal of becoming a better athlete in that specific area. How is the numerical model created? The numerical model is based on the technical model comparing our data collected, now basing our comparison with elite players or pro athletes, instead of our classroom players, as well as expected or normative data that is usually standardized and generalized. For example, elite players, okay players, and maybe casual people or just normal players can be based off of many different aspects. For example, their height, mass, time it taken for them to complete a race, speed, vertical jump, power. The numerical model is the actual raw data that is collected from the appropriate tests that can relate to basketball training. In our testing, we have chosen the three-quarter court sprint and standing vertical jump testing. Elite performers have great skill and ability, athletic ability, and their technique is also at an elite level. That is why they are considered elite. Therefore, by holding ourselves to that standard, it is a good way of comparing our data. The high level athletes, as their data, if they were to do the exact same test, would be incredibly good and possibly the best you can get as an athlete in the sport. This shows that if we do some training and training that they do, this will most likely help us improve to get to closer to a level that they're at, even if it's only a very small margin at a time. Once the numerical model has been identified or created, you can then compare people to it. To make minor biomechanical adjustments, this can increase your efficiency to perform technically better. There are multiple ways that you can receive reliable data and collected from outside sources, such as academic journals on the subject at hand. These are usually also peer-reviewed before analyzing. Specialist literature, blogs, or magazines, these aren't as good as they can sometimes be inaccurate and not portray the right things, but you can use them for more broad ideas or topics.